All right, so let's talk about the midpoint formula. So if you draw a segment like this, right? That's not really a segment. So if I draw a segment like this, and I've got a point A, point B, and point C. If I say that B is a midpoint, then what do you assume about B?
It's in the middle.
It's right in the middle, right? It divides segment AC in half. And so that means that AB equals BC, right? If B is a midpoint. Now remember, if I write AB like this, I'm talking about the length of the line segment. If I wanted to say that the lengths of two line segments were the same, then I wouldn't write an equal sign. I would say those line segments are congruent. All right, so just to kind of get you to remember what we mean by congruency versus equality. When we use equality when we're talking about the actual lengths, when we're just talking about what represents a line segment, when we say if their lengths are equal, then we say those line segments are congruent. Okay, that's going to be important when we start doing some of these proofs later on. All right, that you understand the difference between congruency and the actual and lengths actually being equivalent. So if I had something like this and I had maybe line L, we'll just say line L passing through that point there, then I would say that line L is a segment bisector. In other words, line L passes through the midpoint, and so it bisects that line segment. In other words, anytime you use the term bisects or bisector, you're saying that it splits it in half. Okay? L is a segment bisector. Cuts AC, line segment AC in half. All right, so what if we have a graph then of a line, and let's say the line runs from here to here, and we want to figure out what the midpoint is of that line. The way that we would go about finding that is we would use the midpoint formula. And the midpoint formula says that if this here is x1 and this is x, draw a dotted line down there, this is x2, and this is y1, and we draw a dotted line over here to show that this is y2. And this is point A, and this is point B. Then we would say the midpoint of segment AB is x1 plus x2 divided by 2. That's the x coordinate for it. And then y1 plus y2 divided by 2 is the y coordinate of the midpoint. So if I were to actually draw the midpoint on here, my y value would be y1 plus y2 over 2, and my x value would be x1 plus x2 over 2. So that's how we can find the coordinates for the midpoint of a segment that's on the graph. That's a graph of a line segment. So let's do an example in the book. This is example example 1 on page 35, and it says find the coordinates of the midpoint. Find midpoint of AB, where A is the coordinate -2, 3, and B is the coordinate 5, -2. All right, so this is just example 1 in the book, page 35. And so this one's really straightforward, right? If I signify the midpoint by a capital M, the coordinates for the midpoint would simply be x1 plus x2 over 2. So we're going to write down the formula again, and then we'll just plug in the values. I would always recommend writing the formula down. 1, that tells me you know the formula, and so you'll just get some credit for getting the formula right. And it also helps us not make mistakes when we're plugging in, right? So write the formula down, show your work that way. So x1 in this case is -2. -2 plus x2, which is 5. Again, does it matter which point I make x1, y1 and which point I make x2, y2?
No.
Doesn't matter, right? Because I'm adding them together. And when you add two numbers together, it doesn't matter which order you add them in. But again, like all of our formulas, when you start with one point, if I'm going to make B my x1 and y1, stay with B for the first number and point B for the second number. Okay. Even though in this case it won't matter. You just need to get in the habit of doing that. So -2 plus 5, that's my 2x coordinates divided by 2, comma 3 is my y1 right here, and then -2 plus a -2, which is a -2 over 2. Right? And so that's going to give me -2 plus 5 is going to be +3 over 2. 3 halves is my first coordinate, and this is going to be 1/2 is my second coordinate. So that's the coordinate for my midpoint. Any questions about that? Yes?
Do you use a graphing calculator to do this?
In here, no. In my pre-calc class, yes, you could. But yeah, in here, we're not using graphing calculators. So.
I meant like
Theoretically, yes, absolutely, theoretically. Most of the graphing calculators are going to have a way for you to calculate this. Did everybody follow that? All right. So the next problem is a little bit, it's the same exact idea. We're using the same exact formula, but they give us different pieces of information. This time, they tell us that the midpoint, which is M, midpoint of RP is, line segment RP is M2, 4. So they give us the coordinate for the midpoint. And they tell us that one endpoint, R is -1, 7. And they say, what is point P? So we're trying to find the value for point P here. All right, so how would we go about doing that? Again, there's our midpoint formula, right? So what we're going to have to do here is we're going to have to remember that this here is the x coordinate for the midpoint, and this right here is the y coordinate for the midpoint. Okay? And so then we can say that the x coordinate of the midpoint equals x1 plus x2 over 2. And so what I can do then is I can plug in my value for x that I have for R, and I can plug in my value, my midpoint x right here, and then I can solve for the other x, right? So let's do that. So we're going to plug in a 2 for xm, right? That's my x coordinate for my midpoint. We'll make R the x1, again, it doesn't matter which one we choose it to be, but we'll do that. So So all I've done at this point is just plugged in values, right? Everybody tracking with me on that? Just have to know which formula do you use. And then, like I said, write this down. You write this down right here, you've already got some partial credit as far as I'm concerned. And we haven't done anything complicated yet, we've just plugged in values, right? So now, I want to get the x2 on one side and everything else on the other side. So I got to start getting rid of stuff over here. What's the first thing that I've got to get rid of on this side?
The two.
The 2, which 2? Yeah, well the 2 on the bottom, right?
Right.
Sorry, there's a 2, but that's not really part of
right.
it. Yeah. So right here, I want to get rid of that 2, and it's on the bottom of a fraction, so I'm going to do what?
Gonna multiply it by 2.
Multiply by 2, exactly. Whatever I do to one side in algebra, I'll always have to do that to the other side, right? And so these 2 will cancel out. And so I've got 4 over here, 4 equals minus 1 plus x2. So now I want to get rid of the minus 1. And I do that, if these are added together and I move the minus 1 to the other side, what do I do with the sign?
It changes the sign.
Switch the sign, right? So I want to move this 1 over here, right? I want to bring it over here to this side. And so what I have to do is change it to a positive 1 instead of a negative 1. So 4 plus 1 equals x2. So 5 equals x2. And so now we just have to do the same thing for our y value. We know that ym, the midpoint, the y value of the midpoint is y1 plus y2 over 2. So that means that our y value for our midpoint 4 is going to equal our y value for r, 7 plus y2 over 2. So we're going to do the exact same thing, multiply by 2. Let me give you guys a second to catch up though. Sorry. I'm a little ahead of myself there. I was wanting to sip a Coke and I was trying to hurry up to get my sip. I can take a break, let you guys get caught up, and I can have a sip. Alright, so again, our 2's cancel out. We've got 8 equals 7 plus y2. Bring my 7 over the other side and change the sign when I do that. y2. 1 equals y2. So my coordinates for the other point are an x value of 5. So this is, which one is point P? So the P point is going to be an x value of 5 right here, and a y value of 1 right here. So that's my final answer. Please put a box or a circle or something around your final answer. Okay, help your old teacher out so that I can figure out where your answer actually is on the paper. Okay. Any questions? All right, let's talk about an angle bisector. So we talked about a bisector as it relates to a segment. You have a line or a point that bisects a segment. In other words, it cuts it in half. So what do you think? If I have an angle here, if I have angle A, B, C, and I want to draw ray R and say that bisects ABC, what do you think that ray R probably does? What do we think of when we think of the term bisects?
Cuts through it.
Cuts it through it, but how does it cut it through it? Cuts it in half, right? So bisect, always think of bisect as taking something and cutting it in half, right? 2 equal parts.
So go through B.
So it's going to go here, and it's going to go right through the middle. That's the point, okay? So if we call this ray here R, then what that means, if ray BR, right, that's how I would draw the ray. Actually, you wouldn't have to put the word ray in front of it, because just by having it as this symbol, you should recognize that as ray R. But if ray BR bisects angle ABC, that means that angle ABR is congruent with angle RBC. In other words, these two angles here are the same. Okay? And so either I could say that these two angles then are congruent, or I could say it like this: the measure of angle ABR is equal to the measure of angle RBC. Because that's what congruency means. It means the measurements are equal. So if ray FS bisects angle EFG in this drawing, then what's the measure of angle SFE? Yes?
60.
It's got to be 60, right? And what's the measure of EFG?
60.
It's got to also be 60, because it cuts it in half, right? All right. So I could do, they do an example in the book. I could actually turn this into more of an algebraic problem, and I could say, instead of doing it like this and telling you that the total distance here is 120, suppose I did this. I said, this angle was x plus 40 degrees, and this angle here is 3x minus 20, right? And I told you that FS bisects EFG, and I asked you for the measure of those same angles. Could you find those? Saw like a couple of shakes, yes. Some of you look terrified. Some of you look like you probably went to sleep. Your eyes are open, but you're really sleeping. What is it?
If you gave me an afternoon, I could figure it out. It's been a long time since I've done it.
All right. Well, what do we know? If FS is a bisector, then what do we know about this angle and this angle?
They're each other.
They're equal to one another, right? So it actually turns out to be a really simple problem. It's just x plus 40 equals 3x minus 20. Okay? We set them equal to one another because we know this is a bisector. And so we get our x's on one side. So what I'm going to do is I'm going to move this x over to here. So we'll have a positive x. So when it moves over, it becomes a negative x, right? I want a total positive number in front of the x there. That's why I moved it to that side. Well, if you're watching the video, while the video stopped accidentally, I'm sorry. We solved world hunger during the time that the video was stopped, but then I erased the equation accidentally. So
The cure for cancer.
maybe we'll come up with that again. Yeah. So one of the things we did note, though, if you're watching on the video, is that we had this angle wrong. So this was supposed to say SFG. I was just talking about this angle here. But anyway, yeah, we walked through this whole problem. So just to recap, because we knew fs was a bisector, then we knew that 3x minus 20 had to be equal to x plus 40. And so we were able to put that equation in place there, solve for x, which was 30, and then we plugged 30 back in for x into one of these. We did it in the top one here. We saw that was 70 degrees, which meant that the other one had to be 70 degrees. But we were able to check to make sure we got the right answer for x by doing what? If this was truly 70, if that was right, how can I check and make sure that I didn't make a mistake somewhere? Yes?
They should equal each other?
Yeah, I can also plug it in this one and make sure I get 70 for that. If they don't equal one another, then I did something wrong and I need to go back to the drawing board, right? I probably messed up on my algebra over here somewhere. Okay, it's always good to have a way to check a problem, so it's nice to know that that option's there. So that's it for section 1.3. My video still rolling?
Uh-huh, yes,
Yep,
sir.
okay, cool. So 1.6, will you guys please not go please, okay? 1.6, and let's see what we're going to talk about in this chapter. Angle pair relationships. All right, so the first thing we're going to learn about is vertical angles. Vertical angles. And this is the definition of a vertical angle. If I have two lines that are crossing like this, how many angles are formed by those lines? 4. 4, right? So I've got an angle here, 1, 2, 3, 4. 4 different angles formed, all right? And so vertical angles are the angles that their sides form two pairs of opposite rays. What that means is basically it's the angle that's here and the angle that's opposite that angle, okay? So for this one here, 1 and 3 are vertical angles, and 2 and 4 are vertical angles. Okay? So that's just a definition. I want to make sure that you know the definition of that. The other definition you need to know is what a linear pair is. And so a linear pair is when you've got something like this. You've got an angle formed by a line. You've got two angles formed by a line and then a ray coming off of that line. So you've got like angle 1 here and angle 2 there. So 1 and 2 are a linear, what we call a linear pair. Now for a linear pair, this line here, the line at the bottom there, we'll label it line M. What is the angle that's made by line M? You know, we learned about, in fact, we had this on the quiz, right? We had a line, and I said, what's this angle here? Yes?
It's 180.
180
so it's
is
a straight angle.
a straight angle. We call that a straight angle, right? Right, and so because these two angles formed are formed by a ray coming off of a straight angle, then we know that the measure of angle 1 plus the measure of angle 2 has to equal what? Yes?
The measure of
The line, which we said was 180, right? So for a linear pair, angle 1 plus angle 2, the measure of angle 1 plus the measure of angle 2 has to equal 180 for a linear pair, okay? So let's do a problem here on page 45, problem 1.6. This looks really, really complicated. It's one of those that you just want to, like, if you're going to ask me to do stuff like this, I'm quitting. All right? I'm not going to school. School's over. It's not that bad. As is usually the case, it looks worse than it is, right? So we've got A, B, C, D. And they tell us that these are the different values for each of these guys. This is x plus 15 degrees, and this is 4y minus 15 degrees. This is 3x plus 5 degrees, and this is y plus 20 degrees. And so what we're tasked with doing here is find x and y. Anybody got any suggestions on how we could go about tackling? Well, I'll let you write it down. What, Aiden's already got a suggestion. What's your suggestion, Aiden?
If the two angles, say, let's see, is that middle point?
Yeah, we could label this middle point here E.
If AED and DEB equal 180 degrees because they share that common side.
So AE what?
AED
Yep.
and DEB.
DEB, exactly. So did you guys catch that? Aiden said what he just told us were these two angles here are a what?
Straight angle.
They're a straight angle. What was the definition we just had? They're a linear pair. So because they're a linear pair, then these are equal to one another. Who said straight angle? Yep. What was your name?
Jackson.
Jackson. So you're on the right track. I just want to make sure we don't forget what these terms mean, because again, these terms here are going to be important when we're doing proofs. You're going to say, you're going to be doing steps in a proof and saying why you can come to the conclusion, and you're going to say it's because this angle and this angle are a form a linear pair. Yes?
You could also do the vertical angles thing too, right?
Well, we actually can use the vertical angles for this, but we don't really know, we haven't been given any information about how these angles are related to one another yet. We're going to find out about that in a minute, right? But we haven't been told that yet.
Okay.
And actually in this problem here, it's easier to think about it as a linear pair, because if we try to solve this equation related to these two, we've got an x in one and a y in the other. But if I think about these as a linear pair, then I've got two equations that I'm working with that both have x in it, right? So if they're a linear pair, what I can say is that 3x plus 5 plus x plus 15, right? And let me just write this down. What I'm saying is that the measure of angle, based on what Aiden said, EAD plus the measure of angle DEB equals 180, which I would agree with. 180%. You guys don't get me started. Oh, wow. Yeah, that was, I know it. Okay. I only wish my son was here to see that so he could be totally embarrassed. All right. So the 3x plus x is 4x. We're just combining like terms at this point. Right? 4x plus 10 equals 180. We're going to move the 10 to the other side because I want all of my terms without an x in it move to one side. So when I do that, that becomes 180 minus 10. I change the sign on the 10. So 4x equals 170. And so I'm going to divide both sides by 4. And so x equals 170, what is that, 85? No, it's going to be half of 85. So 42.5?
I got x equals 40, I don't know if I did that right.
Let me see if you did it right. Ooh, you
It's
did. What did I do wrong?
15, you put
Because
5
you
to
put x
15.
plus
Oh, yeah, you're right. Good. Okay, that's 15 right there. Good
and
catch.
then it'd be 4x plus 20.
20, yep. And then we got, move the 20 over here, so this is
Yes,
160.
160.
Oh, that's much easier math. Thank you. All right, so 160 divided by 4, and then that's going to be 40. Yes, okay. Good catch. All right, so that's x. Somebody that doesn't have their name on the board yet, tell me what equation I would build to find out the value for y. I know it's getting tough, like half the class has their name on the board, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 people. Anybody not on the board with the guts? Oh, we have a hand. All right, tell me your name again.
Mary,
Mary, yes.
we do y plus 20
Okay.
plus 4y minus 15
Yep.
equals 180.
Equals 180. Excellent. Excellent job. Because Mary just pointed out another linear pair, right? We have a linear pair here also. We've got a ray EC that's coming off of a line AB. And so we know that y plus 20 plus 4y, we know that the measure of angle AEC plus the measure of angle CEB has got to equal 180. All right, so again, we're going to combine like terms, and we're going to get 5y plus 5 equals 180. And that means that 5y equals 175 when we subtract the 5 from, remove the 5 over and make it negative. And so y equals, what did it say, it was 35?
35.
Yeah, y equals 35. So that's our two. They didn't ask us about the angles, right? I could have done something crazy and said, here's this, find all the angles. Or I could have just to kind of check to make sure that you're paying attention, I could have just said something like, I could have given you this problem that said, give me the measure of angle CEB, right? Just find that one, and just see if you know how to go about doing that. In that case there, you wouldn't even need to find x, right? You just have to find y, and then plug in 35 to that equation there. Okay? So all kinds of sneaky ways that I can test you guys to do, let you do multiple things in one problem to make sure you understand the concepts. Because I'm like that. Sneaky. All right. So, we're good. We're doing pretty good. We're right here at the end. So let's talk about complementary and supplementary angles. Let me just give you a heads up. What we're going to find out, all right, just so you guys know this is coming, is that we're going to find out with vertical angles that the measure of angle 4 is equal to the measure of angle 2, and the measure of angle 1 equals the measure of angle 3. So we're going to find out if they're vertical angles, they're equal to one another, all right?
So you could have used that for the vertical, to find for that.
Yeah, but for this one here,
but it was X
it would be an
and
x and
Y.
y. Yeah, I just said
But you
4y
could-
minus 15, so I could have done that.
Yeah, if it was.
Yeah, if they had both been x's, then that's how we would have done that. And I don't think they're teaching that yet in this chapter. I think there'll be a theorem that tells us that vertical angles are equal to one another, but that's coming. All right, so you can get excited about that in the future. That's like a little preview, right? So we watched the commercial for the upcoming sequel. All right, so let's talk about complementary angles. Complementary angles are like this. So I have and so if I tell you that that angle there is a right angle, and I label this as angle 1 and this is angle 2, then what that means is that the sum of the measure of those two angles added together is 90 degrees, right? Mm-hmm. Measure of angle 1 plus the measure of angle 2 is 90 degrees. And so what we call that is those are complementary angles. Complementary angles, and I'm going to abbreviate angles. Complementary angles are two angles whose sum is 90 degrees. Or actually, I guess technically whose measures, whose sum of measures, technically. Math is so hard to talk about because you gotta say it this way. It's really the sum of the measures that we're talking about. Will equal 90 degrees. All right, and so we would write that like this. We would say L1, the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Right? That's a complementary angle. And then another definition is supplementary angles. Are two angles whose sum of measures are 180 degrees. All right? So that would be like this. And we call this angle 3, angle 4. So angle 3, the measure of angle 3 plus the measure of angle 4 equals 180 degrees. So make sure you know the difference between supplementary and complementary angles. And so it's interesting, as it turns out, what do we call two angles when they're side by side? Does anybody remember? Like angle 1 and angle 2 are adjacent angles, right? All right. It's so funny. Some of you guys are like, right here, and then David's just like, adjacent. I don't care. I don't care that there are 8 hands up in the room. Adjacent. So he's right. They're adjacent. And as it turns out, the definition, notice I didn't put the word adjacent in either of these definitions. Because if these angles were totally separate from one another, right, like this, but if the sum of measure of angle 3 plus the measure of angle 4 still equals 90 degrees, then 3 and 4 would be complementary angles. Okay, they don't have to be connected is the point.
And they can show the same vertex even like that, can't
They could. That's right. That's exactly right. In other words, if I rotated this around here and they were connected together but weren't right beside one another, they would still be complementary angles if their measures added up to 90. Okay? So let's do a couple of quick problems. Problem 5, example 5 in the book on page 46 says, given that, and this is good that we're doing this one because the language here is a little different than the language that we used in our definition. So make sure you know what they mean when they say this. Given that angle A is a complement, angle A is a complement. All right, that doesn't mean angle A was saying nice things about angle C, or vice versa. All right, it means that the measure of those two angles together equal what? Huh?
Sorry,
90 degrees, that's right, exactly. So given that angle A is a complement of angle C, and given that the measure of angle A, they tell us is equal to 47 degrees, and the measure of angle, that's all they give us. Find the measure of angle C. So how would we do that? What you got, Eden?
90 minus 47.
90 minus 47 equals the measure of angle C. Was that Joshua that said that? Is that you? I mean Jackson. Okay. So to reverse this, if we wrote it the way that we wrote it over here, we could say that the measure of angle A plus the measure of angle C equals 90, right? And we already know the measure of angle A, so we could plug in a 47 there equals 90, and then we could say that means the measure of angle C equals 90 minus 47. And so the measure of angle C equals 43. Right? So you can do it the long way, or you can do it the short way, like Jackson pointed out, right? And just say 90 minus 47 equals the measure of angle C, which means 43 degrees equals the measure of angle C. I don't care which one you do. I just want to make sure you understand it, right? And like I said, it never hurts my feelings if you put down this simple, just straightforward equation right out of your notes, so that I see very clearly that, okay, they get what what two complementary angles are, right? And so that's immediate partial credit here if I see that. Any questions? So just like they may say this angle is a complement of the other angle, then they might also say that angle A is a what?
Supplement.
A supplement. So let's do the same thing, a supplement of angle C, but instead of 97, we'll say 47, we'll say angle A is 97 degrees. And so all we would have to do here is we would just change this 90 here to 180, right? I should have just left this 47. Let's just do that, because then all of our math will be basically the same except for the 90. So 47, 133? Is that right? 133, yeah, that's right.
Yeah.
Okay, so this would be, instead of equaling 180, this would, 90, this would equal 180, this would equal 180, and this would equal 180, and this would equal 133. All right? You got time for one? Ooh, this is a little bit, this is tight. But let's just set this one up, because this is a little more complicated, all right? They tell us this. They tell us that angle W and angle Z are complementary, which means what? They equal, the sum of their measures equals 90 degrees, exactly. So they tell us that the measure of angle Z, there's an echo, like right here, measure of angle Z is 5 times the measure of angle W. All right, so how would I set this problem up?
So you could go the measure of angle Z equals 5 times measure of angle W.
Angle Z equals, the measure of that equals 5 times, right? The measure of angle W. There's our first equation, all right? And so then, what's our second equation that we're going to use? Because we've got 2 variables, and if you're going to solve for 2 variables, you got to have 2 equations.
Measure of angle Z plus the measure of angle W equals 90?
90, exactly. Perfect. You guys see where she got that? Those are complementary. So now I've got 2 variables, 2 unknowns, and 2 equations, so I'm good. I can find that. The easiest thing for me to do, since I've already solved for the measure of angle Z here, is just take 5 angle W and move it, this should be the measure, I'm sorry. Move that down here in the place of angle Z. So we would do 5 times the measure of angle W plus the measure of angle W equals 90. Don't get confused by this long thing here. That's just a variable, all right? We could change this to a variable if we wanted to. 5x plus x equals 90, all right? As long as we remember that x is the measure of angle W. So we combine like terms to get 6x equals 90. We divide both sides by 6, and is that 15? Yeah. X equals 15. So that means the measure of angle W equals 15. And so we could then take that 15 and plug it back in either this equation or this equation here to discover that 75 has got to be the measure of angle Z. All right. Everybody good? Everybody happy? Nice? Yeah? Anybody have any other questions? Any concerns that you want to share? How's the temperature here? You guys okay? Yeah? Okay. All right, good. Well, go home. Get out of here, right? Or go to your next class.
2 biology.
2 biology. All right. I'll look for the homework assignment in the class. Google Classroom. There it is. Google Classroom. Have a good day.